Okay, so the first question in the review that was asked was, Mr. Can you explain problem 5 on page 40? All right, so here we go. Write the quadratic equation in vertex form by completing the square. And it's a good question to ask because if you took a look at the breakdown, which I'm sure the student did, you might have seen that this was one of the topics that'll be on the assessment. So definitely worth spending some time going over. All right. So this one I won't need the calculator for, but I'll have it out anyway. So first thing I'm going to do is add 8 to both sides. Vertex form, just a side note, same as standard form. So we have negative 8, y plus 8 equals negative x squared plus 6x. All right, I'm going to leave a little blank to complete the square. Then what I'm going to do is complete the square by taking the b value, dividing it by 2, squaring it, then dividing that resulting value by the a. All right, so the b value is 6 divided by 2 squared divided by the a value, which is a negative 1. So 6 divided by 2 is 3, squared is 9, divided by negative 1 is going to be negative 9. So a negative 9 is getting thrown in the gap here. Because I'm subtracting a 9 from one side, I have to subtract a 9 from the other. All right, so I'm going to switch over to black for those keeping score at home. We're looking at y minus 1 is equal to negative x squared plus 6x minus 9. Here I need to factor out the a value. That a value is a negative 1. So I'm going to pull that out of the polynomial on the right-hand side. When I factor it out, it gives me an x squared minus 6x plus 9. On the left side, I have a y minus 1. Back to the right side, I have a perfect square trinomial. If you take the square root of the first and last terms, I'm going to use a highlighter here. First and last terms, take the square root of those bad boys, x and 3, carry down the middle sign. I'm going to go green. Nice vibrant green there for you. Squared. I don't need to bring down the 1 with the negative sign, so I'm just going to bring down the negative itself. You can bring down the 1 if you want. Y minus 1 on the left. Then the last step would be to add the 1 to both sides. And we'll have y equals negative x minus 3 squared plus 1. All right, so that's the vertex or standard form. That's the only thing the question was asking us to do. Write the equation in vertex form by completing the square. All right, so mission accomplished. Now, had it asked us to find the vertex, we'd have to take it a step further, but it didn't. So I don't want to confuse people by making them think that there needs to be more work than there really is. All right, so let's take a look at my remind feed for another question on page 41, question 10. Can you explain how you got to that conclusion? All right, so page 41, question 10. Let's take a quick look. Quadratic function f of x equals x squared minus 4x plus 3 has a vertex at the coordinates 2, negative 1. Find the coordinates of the vertex of the quadratic defined by g of x equals f of x minus 2. Explain how you arrived at your answer. All right, so, well, I guess we should arrive at the answer first before I start the process of explaining it. First thing I'm going to do is identify what the standard form looks like. All right, this goes back to the last problem we just went over. Y equals, or f of x equals, either way, a times x minus h, the quantity squared, plus k. Now, this quadratic has an a value of 1. And one thing that we've learned throughout this whole unit is the a value of your original function and your a value of your standard form are always going to end up being the same. So once you have a vertex, you're pretty much done in terms of writing it in vertex form. Here they're telling you h is 2, k is -1. All right, so we're in good shape there. Y is equal to 1 times x minus 2 squared plus k, so plus -1 minus 1. All right, so y equals x minus 2 squared minus 1. Now, they're telling us to find the coordinates of the vertex of the quadratic defined by the new function, g of x is equal to f of x minus 1. All right, so whenever you're evaluating a function, you're replacing the variable in that function with whatever the new expression is. All right, so when I say g of x is equal to x minus 2, it's telling me take my original function, y is equal to x minus 2 squared minus 1. G of x is going to replace that x, and I'll even rewrite it with a little highlighter here. Put that -2 in there. It's going to replace that x with the x minus 2. And so I'm just going to chuck in a little x minus 2. All right, so that's all that notation is telling us. Replace x with x minus 2. All right, so I'm probably over highlighting a little bit here, but it's for a purpose. This x is getting replaced with an x minus 2. All right, and that's all because of the instruction that was given in the recipe in the notation, the function notation. G of x will now be, just simple subtraction. -2 minus 2 is -4, so x minus 4 squared minus 1. All right, now the h and k values always make up your vertex. So x minus h squared plus k, I'll throw the a in front for good measure, is telling us that h and k has to be equal to 4, -1. All right, because the only way I'm going to get a 4 in that equation is if I replace the h itself with a 4. And the only way I'm going to replace or get a -1 is if I replace the k with a -1. A more, I'll call it analytic way of doing it, would be to take the two things that you're concerned about and set them equal. So -h equals -4. Solve for h. So we divide both sides by -1. And you get h equals 4. You could also do the same thing here. I'm gonna go green for those keeping score at home. We would have k equal to -1, and that one's a little bit more obvious. All right, so either way you can get it. Now, what a lot of people go for is a little bit of a shortcut by saying that f of x minus 2 represents a 2-unit translation to the right. All right, so if you wanted to avoid the algebra, you could actually do that. So the algebra serves as an explanation. So where it says explain how you arrived at your answer, this is a pretty darn good explanation. But what I could say instead is black, or f of x minus 2 represents a 2-unit shift to the right. All right, because it's always that opposite sign. Therefore, 3 dots in the form of a triangle means therefore 2, -1 shifts right 2 units to become 4, -1. The benefit of this approach is any instance where it says just find the coordinates rather than find the function. This question did not ask us to find the function, so you could have just gone with that route. It's a very articulate response. You could kind of streamline that a little bit. It's up to you, but that's the basics of what, or basis of what needs to be there. All right, so let's take a look at my little register here. What do we got here? Next up, on that same page, number 11, how do you find matching solutions? So let's take a quick look. Which of the following equations could describe the function seen in the graph below? All right, so what I would be looking for, aside from just popping each and every one of these into the calculator, is I would be looking for ones that do not have either only positive roots and do not have multiple roots. All right, so if I see one that would have, for example, a negative root, then I would toss that immediately. All right, some of them are a little bit, kind of hard to, work your way around, just because the form that it's in. But at first glance, you see option A has an x plus 2. Let me get my black. Yeah. The x plus 2 would be a negative root. All right, because if I set that equal to 0, gone. All right. Another thing I would be looking at is the vertex. All right. So in the case of E and F, they're already written in vertex form. So the vertex here would be 8, -6. The vertex here in F would be -5, +4. All right. -5, 4 would put that vertex somewhere in the second quadrant. This vertex here is some positive number followed by some negative number. We don't know what it is, but we do know that it wouldn't end up being -5, 4. So we can toss that as a possibility. All right. So a lot of it ends up being a little bit of process of elimination, but there's really nothing wrong with that. All right. Other things to keep in mind would be the type of leading coefficient. For example, the a value in B, a is equal to -1, this parabola should be downward facing. All right, so that's out. If you distribute out D, same deal. A would be equal to -1, downward facing parabola. All right. Now, the danger about a question like this is the circle all that apply. Maybe all 3 of the remaining answers are correct. I have no idea. All right. So what I'm going to do now is, because really relying on the calculator it can be a crutch, but if you use it judiciously, it's not a bad idea. Right. So now I've trimmed it down to only 3 things to type in rather than typing in whatever it was, 7 things, 8 things. So x minus 6. Worst case scenario, type them all in and see what's going on. It could be a mess, so I recommend typing them in 1 or 2 at a time. But I only have 3 things here, so I think it'll probably be fairly easy to flesh out what's going on if 1 or 2 of them didn't work out. And of course, one thing to always bear in mind is accuracy when you're typing into your calculator. Make sure you do it correctly. A zoom 6 would be a good place to start, but then you might have to manipulate your window. As you know from this calculator, I can just do it this way, but It looks like they're all in the same neighborhood. I mean, one's a little bit more to the right, but this graph doesn't have a scale to it. All right, so yeah, just because the black one and the red one are shifted vertically of one another doesn't mean that the purple one is any less appropriate. All right, so they each are upward facing, each have two positive roots. We don't know whether they're real or rational or otherwise, so I'm going with C, E, and G. And I'm gonna go red for those keeping score at home. All right, so let me check my register, see if there's anything else that came through. And that looks like that's it. So I'm going to end it there. And there it is.